In this video, we will talk about another concept known as polymorphism. In the inheritance video, we created a game class extended by puzzle, which is again extended by word puzzle and jigsaw. Word puzzle and jigsaw are types of games. Let us look at the way we normally declare a reference variable and create an object. First, we declare a reference variable, create an object, and assign the object to the reference variable. Here the reference types and the object type are the same. Jigsaw is the type in this case. But since jigsaw is a puzzle, we can also declare the reference variable in this way, where the reference type is of the superclass puzzle and object type is of the actual object, that is jigsaw. Since puzzle is a game, we can also declare the reference variable in this way, where the reference type is of the parent class game and object type is of the actual object, that is jigsaw. Polymorphism is the ability of an object to take on many forms. In object-oriented programming, polymorphism is the ability to use a reference of a superclass to refer to an object of a subclass. But how is polymorphism really useful? Why would we want to assign a jigsaw object to a game reference type instead of a jigsaw reference type? Let's explore the benefits of polymorphism with a scenario in a gaming application. Suppose when a user quits the game, we want to save his score and the time he spent on the game. The purpose is to record game statistics when user quits the game. We will write a separate program for recording the game statistics. The class GameStatisticRecorder defines a record method for each specific type of game in order to record statistics. Now, we need to add logic in the quit method to call the record method of the GameStatisticRecorder. Rest of the classes do not change. If you observe, we are passing this as argument to the record method. This refers to the current object, the object whose method is being called. Let's create an object of jigsaw. When the game is quit, it will call the quit method inherited from game superclass. The current object will be an object of jigsaw, so it will be passed to the record method of GameStatisticRecorder that accepts a jigsaw object argument and jigsaw details for the player will be recorded. Do you see a concern with the GameStatisticRecorder?
Yes, for each and every class and subclass of the game hierarchy, we need to define a record method. This is too clumsy.
Very good. What else?
If we introduce new types of games, we will need to change the GameStatisticRecorder code.
Excellent. Can you think of a way to fix this? Well, we talked about polymorphism. Using polymorphism, we can assign a subclass object, jigsaw, to a superclass reference, game. So, we can write the record method using polymorphic arguments. The method parameter can be a superclass type and any subclass object can be passed to it. Thus, we saw an important benefit of polymorphism, that is, it allows us to have polymorphic arguments. Similarly, a method can have polymorphic return types. Also, we can make polymorphic arrays. Let's see an example of polymorphic arrays. Declare an array of type game. This can hold objects of type game. Let's put some objects in the array. We can actually put any subclass of game in the game array because the reference type declared in array is of superclass type. And here is the best part. We get to iterate over the array and call play method, and the play method of the actual subclass object gets called. Let's recap. In this video, we learned that polymorphism is the ability to use a reference of a superclass to refer to an object of a subclass. We can assign subclass objects to superclass reference variable. Polymorphism enables us to write methods with polymorphic arguments and define polymorphic arrays.